exercise 7, molar mass and number of molecules, not only will we be calculating the molar mass, we will also be using Avogadro's number to calculate the number of molecules. So isopentyl acetate, which is C7H14O2. Again, I don't have to know that the proper name for this is isopentyl acetate. I just don't. It's the compound responsible for the scent of bananas, and it can be produced commercially. Interestingly, we use the term interestingly kind of loosely here. Bees release about 1 microgram, and if you don't remember that micro is 10 to the minus 6, gives it to you right here. Bees release about 1 times 10 to the minus 6 grams of this compound when they sting. The resulting scent attracts other bees to join the attack. Right? You may know that. You may not know that. You don't have to know. It's not important at all. They tell you bees release this mass of the compound when they sting. So when we go down to A, calculate the number of molecules of isopentyl acetate, this stuff, released when in a typical bee sting. We are calculating how many molecules are released when this much stuff is released. So let's get our flow chart here. We need to go to number of particles, right? That's where we need to go. But what we've been given is a mass. Notice that according to this flow chart, we cannot go directly from mass to number of particles. We have to go through number of moles first, then we can go to the number of particles. So we're going to use the molar mass of the substance and Avogadro's number. So if we're going to start by using the molar mass of the substance, we better calculate the molar mass of the substance. So there are 7 carbons. There are 14 hydrogens. And there are 2 oxygens. So, do some calculations here. 7 carbons, 14 hydrogens, and then what, 2 oxygens? So we come up with a molar mass of 130.21 grams per mole. Now, actually, I'm going to bring that back. This is not an answer. This is just a piece of information that we need to get to the answer. So remember, we have to go from this grams to moles, and then from moles to molecules. All right, we just calculated that for every 1 mole, there's 130.21 grams. And from Avogadro's number, we know that for every 1 mole, there's 6.022 times 10 to the 23rd molecules. So let's double check our units. Grams will cancel, moles will cancel, and we'll be in molecules. Right? And isn't that what the question is asking for? So now let's do some calculator work. Alright, so 1 second EE minus 6 divided by, I'm going to go divided by, you press the up arrow to pull that number down. So I pressed up arrow and then enter. Then I'm going to multiply by Avogadro's number, which remember, on this calculator I have stored as A. So I have, let's see, what is this? A whole bunch of calculator vomit here. This can't possibly be how many significant figures I should report my answer in. So let's look back to the question to see how many significant figures I see the only information that they've given me here is this term, and this only has one significant figure. And so I'm going to have to report my answer with one significant figure, which might seem lame, but that's what the question calls for. So here's my one significant figure. What does that 6 tell me to do? Round it up to 5. That that E stands for times 10 raised to the 15th power. So that is a lot of molecules of isopentyl acetate that are released on a typical bee sting. Next up, calculate the number of carbon atoms present. Carbon atoms present. So let's see here. Now, I know that there are 5 times 10 to the 15th molecules of this stuff. But I also know that for every 1 molecule of this, there are 7 carbons. So what I'm going to do is I'm going to take this number, right, the 5 second EE15. I'm going to take that and I'm going to multiply it by 7. Right, is that fair enough? I have this many molecules. For every 1 molecule, I have 7 carbons. Is everyone okay with that? I hope you are. So I end up with 3.5 times 10 to the 16th carbon atoms. All right, are we okay with that? But the problem here is that this is not correct number of significant figures. Why? 1 significant figure. All of a sudden I have 2 significant figures. This has to be 1. I'm going to round it to right here. So what does this 5 tell me to do? Round it up to 4 times 10 to the 16th carbon atoms.